My name is George Bono. I'm a member of Mount Rainier N-Scale. I've been with them almost from their beginning, with a little sabbatical in the middle. And tonight I'm going to take and give you my presentation of what I've been doing here for the last 4 to 5 months, and that's 3D printing. And we'll do a little bit, but first I have a disclaimer for us. It's not disclaiming. Mouse, okay. Got buttons, all right. So the first one is I'm not a 3D printer expert. I'm a beginner, and any data or misinformation that is here, I didn't plan that. The second one is I'm not sponsored by anyone. I've done all of this with my own money, and I don't have any reason to promote one product over another other than my personal preference.
Okay.
Yes.
All right. So why do I want to buy a 3D printer? Well, I said to myself, I could make some really cool stuff and add that stuff to my layout. And when she asked me the same question, that's what I told her. I can make some really cool stuff for my layout. But then my grandson, Aiden, who is a computer science student at UW, got his first Ender 3D PLA printer. The D&D prints he did were really great, and I decided to look into this 3D thing more. Where would I go to get good information? Where else? YouTube. So I found a literal utopia of channels about all the different printers and materials that you can do 3D printing with. So, and unless you're not familiar with 3D printing, this will be informative, but otherwise it might be kind of boring. But there are basically two kinds. FDM printers, which are fused disposition models. They use filament, so we'll call that a filament printer from now on. And it uses PLA, which is a type of a plastic, and it is actually biodegradable. There's a disclaimer later on not to eat that stuff. The other one is an SLA printer and stereolithography, or a resin printer, which uses a liquid polymer in a vat cured by UV light, and that's the simple answer, because it's not simple. It's pretty complicated, actually. Actually, they both are. So what are the pros and cons, I said to myself? They all have them, right? Well, the amazing details on the resin printer just blow your mind, especially when you're dealing with miniatures like we do in N-Scale especially, but all model railroaders deal with details. They have some really, really cool stuff. Also, it'll print everything on the plate at one time. And that's quite an advantage because that means you can print faster and more items at the same time. What are the cons to resin printing? Well, generally costs, but that is going to change pretty soon. Right now, there's a $100 resin printer that you can buy. It requires removal of support material almost exclusively because they print most of their, not all of their prints on an angle to get better resolution out of it, from what I understand. So you're gonna spend some time chipping away at all of these supports. It requires additional equipment. It needs to be cured and washed. And alcohol is one of the common cleaning agents in this. Of course, it's toxic. And so is the resin. Both of those are, you need to use safety equipment when you're handling it. And it requires an economical, easy for me to say, an ecologically way to dispose of the alcohol, especially. The resin will cure and it's safe to dispose in the trash. The filament printer, on the other hand, is usually less money to buy to begin with. The filament, the PLA, is not toxic, it's biodegradable, and exhausts very little fumes. And I didn't mention in the con part of that, the fumes of the resin printer are also hazardous. So if you have more than one of those going at a time, and I think we have some folks that have experienced some of this, you may have an allergic reaction or some kind of toxic reaction to the resin. But PLA isn't that way. I print right next to it all day long when I'm printing at home, and I can't even smell it. And that's a benefit. When you're finished printing, there's usually not very much cleanup. Here is a picture of a tunnel portal that I printed. It had indentations and cornices along the top of it. And I didn't have to do anything at all to make this look better. Prints can be durable and are used in industrial applications many times. And there's a wide variety of PLA products available. They kind of range from the typical plastic-ish PLA right up into combinations with carbon fiber and even metal. But it requires, one of the disadvantages of that is that you can't just do that with any printer. It requires a special printer. And the new printers can print more than one color at a time. So as you can see, that one's got 4 spools on it, and it can do some stuff. Okay, what are the cons for the filament printer? PLA is sensitive to humidity, so we don't have too much humidity in our neck of the woods. So, it'll work out just fine. And what happens is that it gets absorbed into the material, and as it's extruded at 200 degrees centigrade, the vapor particles in the PLA will explode or vaporize instantly. And instead of getting the filament, you get nothing. So it'll create bumps and voids and all kinds of things in your prints. Filament printers can only print one item at a time on the build plate. Now you can have 10 items on there, but it will go from one item to the next in sequence, and they'll all be done that way. Whereas the resin printer does them all at one time. Big difference there. While there are many different filaments, not all printers will be able to use them due to the heat requirements. And also, printers can come in different configurations as fully assembled, which usually the resin printers are. Some are partly assembled, and others are kits, like this Prusa kit right here, Prusa kit. That takes about 8 hours to put it together. Now, I didn't write it down as an advantage, but when you do a kit like this, it really makes it easy for you to replace the parts on it when they break, and they will break. So you've got an advantage over myself, which I didn't have to build a kit. I'll explain that one in a bit. So this is basically the parts on an FDM printer or filament printer. You got the frame, which is pretty obvious. That's the big black stuff there that's holding everything together. We have an extruder, and the extruder sits in the frame right there on the y-axis, I believe that is. I don't really remember which way they go, except Z goes up and down. Then you have the Bowden tube. Now, there are 2 basic kinds of ways the filament gets put into the top of the printer head. The Bowden tube is one, and it's a combination of a tube and a gear drive that feeds it down the tube into the printer head. The other kind puts the filament right in the printer head, and that's called the direct drive. Most of the inexpensive ones are the Bowden drive kind. Then you have the hot end, and the hot end is the business end of the printer. This is shows all 3 parts to it. You have the heat sink, which is that big section up here, and then you have the heater, which is in between the nozzle and the heat sink, and that's what really does all the cooking. And then, of course, you have the nozzle, which is the next part here. The build plate is where the castle is sitting on. Almost always they are heated to help keep the filament in place while it's being moved around. This particular kind of printer, they don't all do it, but most of the low budget, low end printers do it. The build plate will move back and forth, and the head is going up and down, and they kind of work together to make things go in other directions. And it's actually pretty amazing to watch it work. It's mesmerizing. The stepper motors, there are 4 of them. They take and do all the driving, and they are amazing. They can do infinitesimal little movements of it. And these are all belt driven. I didn't show the belts here, but all the drives are belt driven except for the Z axis. They use some kind of a screw mechanism. On mine, I have 2. On the really cheap ones, you'll get 1. There is a problem with that. And then, of course, you have the control box, which is down here in the corner. They have different types of control boxes. And then I have the reel, which isn't shown in this picture, which is where the filament rests. So, okay, I bought an Anycubic Viper filament printer. While I was waiting patiently for the printer to arrive, I was wondering how and what to print. I told the warden when she asked, I wanted to do stuff for my layout, but then I didn't know how to find files to print. I could pick up a drawing program, of course, and that wouldn't be fun, but then that's another hobby in itself. But instead I said, wait a minute, I just have to ask my grandson. So I did. And out of the mouth of babes, he says, oh, Grandpa, go to Thingiverse or Thangs. I said, what? Who? Oh, okay. So off I went to Thingiverse. And I typed in the box after I registered, and I put in N scale trains. In about 10 seconds, I had a list pop up. And when I read the header on top of the list, guess what it said to me? How many STL files do you think it told me I could find?
250,000 plus.
Anybody else?
About 1,000.
Okay. That's pretty close. Let's go to the next plate. Here we go. Bingo. Here's 190,000 files. Now I typed in N scale railroading, very specific parameters. And believe it or not, as crappy as their search engine is, it gave me everything that I wanted first. Then it gave me anything in railroading, anything that they wanted, and anything they sponsored. I don't know how I got all of it. But I said to myself, well, gee whiz, if N-scale railroading brought up almost 200,000 files, what would model railroading bring up? Any guesses?
2 million.
Yeah, it wasn't quite 2 million, just 900,000. So I said, oh, I'm going to spend some time on the computer here looking for files. Well, anyway, my Viper finally came, and we assembled it. Now, my Viper is right in the middle of the kit versus fully assembled section. It has 6 screws to hook it up. You hook up the wires to all of the motors and the sensors. You take and change the power requirement on the back on the switch from 240 to 120. You stick in the memory card and you pop up the Benchy on it and you're printing. It took 20 minutes.
So the Benchy is.
The Benchy is this owl.
Okay, but it's
A Benchy is a benchmark.
Okay.
And that's to give the printer an opportunity to show you what it's capable of. Now, I have to admit, I brought it with me, and my grandson and I were flabbergasted how really smooth the back end of the Benchy is. And the owl has got, there's nails on his toes and there's grain in the log that he's sitting on. And there was hardly any stringing or globs or anything on him. He was pretty much ready to paint him, and I did paint him. So that turned out to be quite a deal. I was impressed. So now what? You need to install the slicer software, came the voice of youth. There are 2 ways to input print to this machine. The first one is you take a file that you drew or you found, put it on an SD card and stick it in the machine and run it. You're going. Now you can actually do more than one file. but you have to take the item off the print table when it's done. Some places have that done automatically. Not automatically, it's automatically. And they keep printing all day long until they run out of filament. Then some poor slob comes along, puts more filament in it. But I don't particularly care for that method. So I went for method number 2. I connected a USB cable from my printer to the computer. But now you need to take and slice it when you do that. Or you convert it, the drawing, to a G code, is what the printer uses to print. And the slicer, Cura in this case, is free from the manufacturer, which is Ultimaker. And there's Cura's logo. Okay, so this is a sample page of Cura's software. And this is a tunnel portal that I actually have the part of it out there in the back for you to look at. This is actually the size of my print table. So when you load your data into Cura, it knows everything about my printer, even though they didn't make it. They have everybody's printers in there, and they set up all the parameters. So they know your print size, they know your temperature characteristics, all of this kind of stuff. And that's really important. And actually, there isn't too much here in the slicer that isn't important, because you'll be amazed at what it can do. So for instance, if I get an HO file that I want to put in here and slice, I don't want to print an HO file. I'm an in-scale guy. It'd be too big most cases, unless it's something unusual. I can change the size right in the slicer. I don't have to go back to the drawing program and change the file. Actually, you may not be able to change the file in the drawing program anyway.
Do you change it by a percentage, or?
You can do a percentage, yeah, or you can change it by millimeters. But I usually use percentage, since for N scale, if it's HO, it's 54%, and it works out perfect every time. The other thing is you can flip it around. So this is an interesting thing. One of the things that I printed first was a snow shed, which is in the back over there, and I printed it like I got the file, which was like the opposite of what you see this tunnel portal. It was flipped 180 degrees. So the base of the snow shed is sitting on the ground and the arcs are facing up. Well, as you'll find out here in a minute, you can't do that. Not like that. You have to support any part of the print that's extending over a certain degree, because it cannot print in air. It needs a surface to land on. This is basically a high-tech hot glue gun. And if you were to take your hot glue gun and just hold it up in the air and let it go, it ain't gonna go anywhere but down on the floor. And it's almost the same thing with this. As a matter of fact, it's identically the same thing with this, because I've had that happen to me too many times. So my grandson says, "Hey, Grandpa, why don't you print it upside down?" So I flipped it over upside down, printed it without any supports to help the arcs. And we'll talk a little bit about supports. Well, you saw it a little bit on the resin one. They're a little different in the filament ones. But basically, I had no supports. No supports means no filament, which means no printing time, no extra material. I cut the time in half and used half the material. Out of the mouths of babes, right? And you can also pick how many you want to print. So it's got some flexibility in that regard. So this is the profile tab on Cura. There are 14 files listed there. And out of the 14 files, you'll have approximately 250 choices that you can make to help you determine how to construct your print. Now, they don't all apply, but it's amazing when you change one, what it'll do. For instance, I'll give you a good one. the default speed for this printer to move is 50 millimeters a second. That's basically 2 inches a second. And, but I can adjust the speed. Now, what is speed? Speed saves you time. May not save you quality, but it'll save you time. And I said, I'm experimenting anyway. So I cranked that puppy up to 80 millimeters a second. So now I'm over 3 inches a second. And in place now, when you click on these guys, you'll get another whole menu of stuff. For speed, I can tell it how I want it to go when it's not printing. So say I'm printing those tunnel portals that I had there. They're set maybe 3 or 4 inches apart. So when he's over here, he's gonna print everything on a layer. Then he goes up to the next layer and he prints everything on a layer. And he goes up to the next layer, prints everything on a layer. So when he's going from one object to a different object, I don't want him to be printing. He's gonna be dumping filament on the ground. So I shut him off, but I don't want him to go from here to there slow. So I can crank him up to 250 millimeters a second. He's not printing, he slides across. Now, how do you keep him from not printing? The little gearbox up there that feeds the Bowden tube filament to go in there is actually what causes the pressure on the nozzle to force the filament to come out of the end of the nozzle. It retracts the filament. Just as long as you tell it how much you want to retract it. You can tell it how far you want it to retract. So now it's not printing, it's not oozing, and it's moving faster. So you save time, you save material, and you're cooking. But this is virtually my new hobby. I've probably watched, I will say conservatively, 150 hours on just this alone. Now, I don't do it all the time, and I don't, it's not an obsession with me. But what I found was when I'm having problems, I can find solutions to that. Now, I put quotes around the solutions because anybody that has a YouTube channel is an expert. No, he's not. They're not all experts. A lot of them are just like me, where they just are out there banging around trying to make a buck on YouTube showing videos. And they may or may not give you good information, but it is a source of information, and I get a lot. The best thing I found out is that once you run out of dumb luck, the next thing you need to do is to learn how to use these profiles. And when you can use them, you're doing the Snoopy dance. It's amazing. Okay. So I started out and I said, let's do something simple using the default selections in the profile, since I knew nothing about it anyway. And I picked out this guy. So this is a HVAC unit that fits on top of a roof. It's N scale. It's not very big. And wow, that thing came out pretty good. It had a little bit of stringing going on in between some of the small pieces. Didn't take very long to clean it up. You don't have to do that on anything most of the time anyway, I would think. So I was pretty happy with that. So I said, let's do something else. Let's do a small structure. So here's a yard office. Didn't come out too bad, not bad. We'll use our 3-foot rule and N scale, right? Wow, it even printed desks inside there. You see them? And that one desk is actually not solid. It has legs on it. And I'm going, whoa, this is getting really exciting now. So I got a little carried away on this one. I said, let's do something really cool. Let's do this inspection platform. This is where I found out it won't print in there. And it doesn't like whatever it was I was doing to it, because it was hideous. And this is not the worst one. This is the best one. I did six of them before I got this good one. And it's like, oh no, what did I do wrong? So, where are you? Only Superman can operate in midair, not a filament printer. It needs help in the form of support towers. So this right here is test support towers. And as you'll see in the back room over here in the back of the room, there are a multitude of test towers. And the support one will really help you realize. So when you look at the little ledges that are hanging out on the right-hand side of the right and the center and the left-handed towers, they are pretty much telling you that it could support that far. Anything further than that, you can't do it. If it was bad, it would be drooping or it would do something else. Plus they block it. Hello.
George.
You can change the criteria on the support towers. So as I started to get into it more and more, and I got more and more failures, it dawned on me I needed to do more tests. So I went back to my YouTube mentors, and they were telling me to do this, do that, check this, check that, do that, do this. And this is just a minor amount of test towers and instruments that I use to do it. I really like the cat though. That's what do they call that? A Cali-Kitty. And it does like 6 different calculations and tests for you in one shot. The thing that's amazing when you think how this is a $230 machine. I had bought locomotives more expensive than that. And that had nowhere as much fun as this, but this guy right here is 1 square inch, and it's less than 2/1000 off all the way around. That's pretty amazing. Anyway, test. That's the name of the game for this stuff. So 3D printing is akin to a Major League Baseball batter.
When Farley's
Hello.
5T.
Let's test your baseball knowledge back here, guys. First one.
Turn on, mute your computer, please. Who's ever talking in the background?
Okay, ready? So what Major League Baseball player had the highest lifetime batting average, and what was it? Who knows? Yeah, no.
Babe Ruth.
Babe Ruth. No, not Babe Ruth. Okay.
I don't know.
This is amazing. This Ty Cobb batted .360 over 24 seasons. That's crazy. Oh, how about the next one? Who had the highest single season batting average? Anybody know? Ted Williams hit 400 for an entire season. That's amazing. If you could do this good as a 3D printer, you will be a rock star. You could hit a home run every time? No. So here's a couple of my home runs. The sawdust burner on the side was a file that I got off the internet. It came out, the only thing it had on it, when the printer finishes, it always gives you a little tail. And it's on the very top of that. Now it doesn't print a grid up there that you can see through, but a resin printer will. That's the snow shed that I did, and I did about 8 of those, and the last 2 of them that I did are absolutely amazing. I learned how to use the profiles. It's stronger. The little legs on the outside are a little weak, but the ones that I printed lately are absolutely impregnable. Well, maybe not impregnable, but they're pretty strong.
Yeah, hold this.
Oh, here's the other end of the baseball analogy. This is a three looking strikeout victim. Anybody know what that is?
A mess.
I don't even remember. I think it was one of those inspection platforms, but I don't know. Now the bridge up there behind it was a triple. It wasn't a home run, but it was pretty close. I had to spend about 20 minutes to dig all the little stringers that were in between the arches all the way back and forth. But the stone part of it and the arches, there were no supports on this. It came out really, really good. That was a lucky triple. So some lessons I've learned from 3D printing from the School of Hard Knocks. This gets me every time when I don't do it. Never assume a file from the internet is correct to print. Put it in a drawing program to check it for size, etc. The slicer will let you know if it stinks. So this is all vector drawing stuff. Don't ask me what that is. I just know what that is, but I don't know what that is. And if it's not right, the slicer Cura will throw a notice at you that it's got an error in it, and you go and do it. Now, I did try to fix one time that I really wanted to print, and I found another program called Mesh Maker, which is what they do with this stuff. They make a mesh out of it, not a mess, but a mesh. And I couldn't get it to work, so I still have learning process there. If you do a drawing, check for connectivity of components, right, Dennis? The printer will print it even if it's not connected anyway. So what happened was I was in a drawing program called Tinkercad, which is kind of like the ABCs of 3D drawing, whereas the other guys are all Phi Beta Kappa, PhD students. But it works, but it doesn't always snap the way you want it to snap, like some drawing programs will do. And we were putting together something, and it came, when we started to print it, it was printing it wrong because I hadn't connected the parts correctly in the drawing. And the printer will print it because it's not wrong to the printer. It'll try and do it. Okay. Always pre-group print from bottom to top, looking for errors of non-printable spaces. Cura will color them for you. It even has a color perceptive sensitivity setting, which is for us colorblind guys. And I can see the colors because I'm colorblind. And that was really a nice little feature of that software. So what I'm saying is, when you put your print in Cura and it slices it, it'll let you preview it before you print it. And you can look at every layer. If it's got 10 layers, you can look at every one. If it's got 350 layers, you can look at every layer. And you can see what it's gonna do. You can actually animate the printer head, and on the layer that you're at, it'll show you how it's gonna print it. So that there's something to that. I don't know what yet. I haven't gotten that into it. And I don't hardly ever use that. But I do look at the bottom layers, because if it's not touching the build plate, it's floating in the midair, and the printer will drop the filament all the time. So that's a biggie right there. Never leave the printer on the first layers. More problems will show up here when you print them then. And that's 85% of my problems have been right in the first 2 or 3 layers. And I can stop the print and find out what's going on and do it. I printed one wall section of the wall that I have in the back room, which is kind of a eagle block wall where they're stacked on each other. And I wanted to do another one, and it wasn't starting out right. It was globbing filament all around the place. And you got to remember, this is moving a fraction of a millimeter every time it goes around, generally. And so if you go around and you got a glob that's sticking up, it's going to either smooth it out or it's going to grab it. It's going to catch on the side of the nozzle, or even if it's big enough, it'll catch on the size of the heater head, the hot end, which I have an extruder over there you can look at that did that. That was the black one that was there, that mess. And it'll ruin your print. I didn't put the picture of it in there when I got there. It didn't look like the picture. It was stuck to the whole thing, and it was about the size of a baseball. And yeah, and that's what I about fell on the floor, thought I was dead. But you got to be able to watch it at the first bunch of times. Every once in a while, you should go back and watch a long print just to make sure. I've had them come off the plate a little bit in certain spots. Again, once you change that elevation of your print, the printer head can come around and grab it. And it gets hard after a while if it gets up off of the heated surface, because now you're not getting that heat to the plastic, and it gets hard. It's like a brick. Okay. Check it while it's in progress. Don't assume that the profiles you have loaded. Don't assume that the profiles you have loaded could be the best use of material and time. So I've done a few of these where I modified the profile, all of those 14 things with 250 changes, and I can save those. And I give them a label so I know what they're for, and I can save them. And whenever I pull up a list of the profiles, it'll be included in the default ones and the ones that I've created. But sometimes they're not going to work right. And again, you can almost tell that somewhere in the middle. And I have one print back there that's a partial of I'll give you a good example of a grain elevator, an old wooden grain elevator. And I started it out and it was going just fine and dandy and I was loving it. And I walked away and I came back about, an hour later, and it got up about an inch. And I looked at it and I said, oh my goodness. So I didn't talk about this at all in this presentation, but when you have a void in between the walls of your print, sometimes you need to put an infill in there to strengthen it. Now, most of the time I found if the walls are thick enough, you can add layers of the walls. You don't need infill. But this one, it's going to be about this tall, and I wanted to put infill in there. But I put a very modest amount of it in there. But when it connected to the outside wall, which was only one layer thick, you could see the ribs of the infill. Now, it's N scale, you paint it, put it over there in the corner, nobody's gonna know. But I said to myself, no, I can't do that. So I stopped it. That profile that I had was for a bridge, completely different profile. And so I couldn't really add more walls to the bridge, like a plate girder bridge. It's not going to give you 5 plates. It's not going to do it. They're only going to get one. At least I haven't found a way to do it. So that is how I got burned on that one. And it wasn't overly painful, but it was. So there are some times when you're going to get a really good profile. And like I mentioned, you can save them, put a label on them so you know what they did best at the time and go. And if you get a problem, break out the test towers, start tasting your stuff. Or if you change filament, now you could even change, right now I bought a rack of filament, 8 rolls that I brought 8 rolls. They're not very big rolls, but that's fine. It was reasonably priced. And I'd rather go through them quickly and not them get all full of humidity and cause problems, because I kind of had that on the first one that I did, first big roll. If you change rolls, irregardless if it's the same company, and if it's a color change or something, if it's all the same color, I wouldn't think you'd have to do it. But if I have 8 different colors, and the best thing to do is to run your tests, run your stringer test, run your temperature test, run your retraction test. All of those, there's a half a dozen of them that you can run, kind of a baseline test. Do your test before you start printing, so you don't wind up getting issues later on. Where are you at here? Okay. So here are some of my prints that I've printed so far. These are not all of them. Some of these are good ones, and some of these are not so good ones. The big gas tank in the back looks really good from here. That's the 3-foot rule. But if you look at the thing, it's got little holes in it, and it didn't print out good. I did put supports on the bottom of it, and it's terrible. They didn't want to come off. They ripped all the pieces of it apart. Like I mentioned before, that's the sawdust burner. It works great. I love containers. You know what containers cost these days? Those cost 12 cents. And they take about 30 minutes. And the small ones, of course, less. Tank containers, the gondola load there is a bunch of dental caps that my son-in-law gave me back when he was back in the Stone Age dental school, where they used aluminum dental caps for temporaries. You might remember that. And I said, hey, let's make the gondola load out of that. That looks pretty cool. It looked like some kind of thing in there, right? And I weathered them all up, and it derailed on me and threw the suckers everywhere. I couldn't find them. And I said, oh my goodness. So then I said, well, why don't I just go ahead and get them? I had about 5,000. Why don't I glue them on there, and then I don't have to worry about it. I said, wait a minute, I can 3D print those. So I went to Tinkercad, my drawing program that I use, and I stuck the dimensions in there after I mic'd them out and printed them up and put them on a slab and all at once. And that's one giant piece of gondola load that I haven't painted yet. So my good buddy Dennis back here, he's got a really nice rock quarry he's building. He says, hey, George, can you print any conveyor belts? And I said, well, let's find out. I haven't looked for those. So I found this print of a conveyor belt, and I started to manipulate the size of it, but actually it's not bad. And you're not going to believe it, but it printed the rollers underneath the belt. And absolutely no cleanup on that. The motor ribs and everything, you can see them all. It can print really small parts. So some of those in the middle there are bridge shoes, and they came out pretty good. That's a chimney, double stacked chimney. I tried to print a big, I don't know what they call it, but it's a movable bridge shoe. That's the white one over on the left. It came out really bad. But all in all, some of the small stuff is not bad. Here's a few more bigger things. The buildings are iffy. You can get some good buildings, you can get some bad buildings. A lot of the buildings, the files that you can get for free are mostly some kind of a kit. So you're gonna have to build walls, build windows. The windows are usually really clunky. I think you'd be better off buying third-party windows. And the big gray beam with the 2 holes in it are gonna be my support beam for my 38th Street overpass over the Tacoma Gulch. And I took a, what was it? 3/16 Dow, I mic'd it, put that dimension in my drawing program, it printed the holes perfectly. So the Dow doesn't even need glue. It's amazing. So what's my verdict after 4 months or so of printing? Will 3D printing have a future in model railroad for the average guy? Can the average modeler do PLA printing or SLA printing? Can the average modeler do simple drawings, files for railroads? And the answer is, I need more filament. Anyway, thanks for hanging out. I appreciate it. If you got any questions, I'll floor them. Go ahead and turn them back on if you want. All of that. But the only guy that can not answer me any questions is Chip.
Okay, questions?
Hey, Chip, you can back me up on this if you want. Go ahead.
Very good presentation. Very thorough. Good job.
Thank you. Say it again.
Samples of 3D printed parts, may I put them out?
Yeah, sure.
Thank you.
Yeah.
Hey, George, you mentioned one thing you were having trouble getting the print off the hot plate. Take the hot plate, stick it in the freezer, it'll cool down, it'll peel off real easy.
Actually, I don't have, if I said that, I made a mistake. I have a magnetic hot plate on my printer. And I'd have to do absolutely nothing to it.
Okay,
It's amazing. The other, like my grandson's Ender, he has a glass hot plate and he has to actually put glue on it.
yep,
So,
same problem I got.
yeah, if you can get the magnetic hot plate, I would get it. It's worth whatever the $30 or $40 you have to pay for it. And it's pretty much even bulletproof. I have my X-Acto scraper blade that I use to get some of these things off, and it doesn't even penetrate it. So it's worth it. The only thing that you're gonna get with it is whatever you build on it flat is gonna be impregnated into the print. And it's very fine. It's almost non-distinguishable for the most part. But for all of the hassles these guys have for getting stuff to stick to the plate and then trying to get it off, it's worth it. I have virtually had no problems with it.
If you want to share with your son, on the glass build plate, if he gets a PEI filament that glues on there, that helps stick. That's what I put on my glass and it works perfectly. Nothing
Yeah,
else.
he's been playing with this filament, so I don't know what he's using now, but he hasn't been whining at me about it. Okay.
Any other comments, questions?
The first thing, let me say this, I have a modest technical background. I'm not ignorant to computer things and drawings and so on. But I was rather cautious and somewhat weary of starting this because I thought it would be not worth my time. And quite honestly, I was wrong. It's been a big giant boost for me, and I'm already starting to print stuff for my friends, which is always a kick because they've always helped me out with all kinds of stuff. So if you are apprehensive about it, it's not a big investment. The only investment that it's going to take is your time. And if you are a good time manager, you can get this done. Or, if you're like me, when you are so tired you don't want to go in the layout room and try and screw something up, you can go and 3D print something. Okay. All right. Thank you.
Okay, we've got a few bring and brags here that I've got pictures for that I'll go ahead and again share those. Start with Chip.
Okay, I'm assuming you can hear me.
Yep.
A friend of mine was on vacation with his wife and happened to go through Colorado. And here they were in Silverton. He encouraged his wife to take a picture of this boxcar, including a detail of the other end of it with the lettering. And they put it on Facebook and then said, "Hey, we challenge you on 3D printing it." So I took this picture. Go to the next picture. And I was able to create the model from this picture. It is ON30, and it's a little bit crude on the grab irons, but he's not a model railroader, and I made it only for setting on his mantelpiece for a souvenir of his trip. And so next picture, I just overlaid it over the other one just to show that it kind of is in the same spot. But based on the picture that he sent me, and then I was able to get some decals. This is the model that I made for him. So when I do it, I'm drawing almost I draw everything that I do. I use SketchUp Pro, and I can do it from drawings or at least measurements of some kind. And in this case, I make all the sides so that I can lay each side flat on the build plate and then put it together, assemble it as a model. There's always some build problems. It becomes a technical model construction. And so that's where that's at. I've got I've done a real quick and dirty of the church up at, in fact, if I can, I don't know if you can see it on my profile. There's the quick and dirty on the LB Church up at, well, LB. And then I also did a car box that's got a removable top and everything, just for fun, put miscellaneous things in it, draw it up quick. So that you can build anything that your mind can make up, so.